Now, we've talked about DHCP in terms of IPv4 addresses, but we haven't talked about it in terms of IPv6 addresses. So I have the protocol header on the screen here, and I want you to look at that, and I want you to tell me what the problem is when you think about what you know about IPv6 addresses. Normal IP addresses, IPv4 addresses, are 4 bytes, but IPv6 addresses are much larger. And what do you know? If you look at this header, we don't have room for IPv6 addresses. There's not nearly enough address space. And this is a consistent theme, right? Any protocol that supports IP addresses and was traditionally bound with a set amount of space for IPv4 addresses needs to adjust to be able to include and be able to accompany IPv6 addresses. And that's not really possible here, right? There's just no room for that within the given protocol header. So instead of actually just retrofitting DHCP to do that, I mean, it was already kind of a retrofit of boot P, so you're kind of bolting on a lot at some point. It was basically decided that it made more sense to create a new structure for a new protocol, which was essentially DHCPv6, which is what you're looking at here. It's defined in RFC 3315, and you can see it's actually a much simpler structure. So we don't have all those static fields that were often blank or empty. Most everything is done via options, so you have the ability to add those different options, just like we saw with regular DHCP. But you still have the static message type and transaction, because those are the things that are actually going to be in every protocol. For the most part, with regular DHCP, all the rest of the fields were entirely variable. Some of them, there were always use cases where some of them would be empty. And when you have required fields in a protocol header that are going to be empty a lot of the time, you're just wasting bandwidth. And we don't want to do that. We want to be as efficient as possible in our network communications. So DHCPv6, a lot more slimmed down. Now, the main thing to take away with DHCPv6 in terms of stimulus and response, and this since we're talking about initialization, is that the process really hasn't changed that much. We're using bigger addresses, and we move some things around in the header. We're using options more now as opposed to required fields. But for the most part, the same structure exists, albeit we have changed terminology a little bit. So in this case, we have another DHCP client, a DHCP server. We're on an IPv6 enabled network, so we're going to use DHCP v6. Both the client and the server are aware of it. Now, before we had the DORA process, Discover, Offer, Request, Act. This process has a few different names. In general, the first process is not discover, it's solicit. The response is no longer offer, it's advertise. And then after that, you have request and reply. You don't actually have act. So request is the only one that's the same here. So that's the R. DORA is now actually SAR, which isn't as convenient of a name. And I like to think of these as characters. I think of Dora, Dora the Explorer, a nice, friendly, good guy character. And then you have SAR, which sounds like the evil stepbrother or something like that. It definitely sounds a lot more evil. But nonetheless, pretty much the same process, just a new acronym and a little bit different structure to support those IP addresses. Now, you might expect here we're going to pivot to the packets, but I actually don't want to do that here. I'm going to save that because we're going to have a lab exercise coming up wherein I want you to actually go through and go through the DHCP v6 communication on your own and pull out some information from it on your own. If you understand DHCP for IPv4, you'll understand it for IPv6, and I want this to actually be your lab exercise. So we'll have that coming up next. Otherwise, we'll be moving on to our next application layer protocol.